Alright, there's only one thing you need to know about binomial theorem. Firstly, binomial theorem means bi. That means you have two. The word bi just means two. Alright, so let's say we have two terms, A plus B. Binomial theorem is the expansion of two terms. And let me be more specific what I mean by expansion. It means that I raise it to a particular power. Okay, that means I raise it to a particular power, let's say n. Okay, so for example, if I have A plus B, I raise it to the power of 2. Okay, what it means is that I have A plus B, A plus B. If I have A plus B raised it to the power of 3, I have A plus B, A plus B, A plus B. The binomial theorem helps us to expand. Bi means two terms raised to the power of n. Okay, and it's a really powerful theorem because as the numbers get bigger and bigger, let's say if I want to raise this A plus B to the power of 10, if you were to do this method and to expand it out, not only will you most probably make mistakes, but it is extremely lengthy and long. But the binomial theorem helps us to do this expansion very quickly. In fact, if you memorize the steps, you can actually do the expansion in a little less than 1 minute. Okay? So what is the trick behind it? I give you an example to help you to recap. And this one, unfortunately or fortunately, you just have to memorize. It is just a memorization game. Okay, if you treat it like a game. So if you have the expansion A plus B raised to the power of, let's say, 5. The method to do this, is you would first write it down, is 5 choose 0. Don't have to worry, for those of you students who are new, don't have to worry what 5 choose 0 is, I'll explain later on. But the method is you'll write 5 choose 0 first. I will write down A and B side by side. 5 choose 1, A, B side by side. 5 choose 2, A, B side by side. 5 choose 3, A, B side by side. I will continue this pattern until I get 5 choose 5. Okay, I will continue this pattern until I get 5 choose 5. Now, what is the pattern over here? I will start with 5 choose 0. I always start with 0. And I will end at 5 choose 5. Okay? Now, this A and B, where does this A and B come from? The A is just the first term here. The B is the second term of the binomial. Okay? We are not quite done yet. All we have to do is just fit in the powers. So how do we fit in the powers? The first power is simply 5 minus 0. 5 minus 0 gives me 5. Actually, you just need to do the first one because the rest will be in descending. Then it will be 4, 3, 2, 1, 0. Okay? So binomial theorem is very simple. You just have to know the first term. The rest you just follow the pattern. How about the B term? The B term will just follow whatever is here. So this is to the power of 0. Then you can increment it 1, 2, 3, 4, 5. So if you notice something, if you actually notice a pattern, you actually don't have to memorize too much. The A, the first term, will be descending powers, starting from the power n. Okay, descending. So 5, 4, 3, 2, 1, 0. The B is ascending. So it will be 0, 1, 2, 3, 4, 5. Okay, this is the binomial theorem. Now, for those students who are not here with us last week, you may be wondering what is this 5 choose 0. 5 choose 0 is just a function, it's just a mathematical function, similar like what is, you guys never learned logarithm, okay, cosine or tangent, okay, it can be calculated using your calculator. Okay, so for the benefit of those of you who are not here, okay, let's choose 5 choose 0. You just have to on your calculator, press 5. The choose, it will be this thing. Can you see this thing? I'll zoom it in for you. Okay, 5 choose R. So I'm gonna press shift, gonna press this button. You will see this C. Okay, and you're gonna press 0. So this is how you choose 5 choose 0. Okay, I'm going to try another one. 5 choose 1. 5 shift this one 1. Okay, enter in your calculator, it gives you 5. Alright. So these are the things that you should know how to do. Okay, so once you actually get here, all we have to do is just calculate what are these values, substitute inside, and technically you are done already. Your job is done. Your binomial theorem is already done. Okay, so you just have to memorize this whole chunk. Okay, binomial theorem is really this whole thing only. Okay, now before I move on, I just want you guys to take note of some important things. Now, do you notice that whenever I have, let's say 7 choose 0, 8 choose 0, 1 choose 0, 2 choose 0, what is the answer to all of this? 1. So can we generalize this? Okay, anything choose 0. So if I have n choose 0, my answer will just be 1. Okay, this is one thing that I need you guys to write down. In your notes, can you turn to the front? Okay, under here. This part, can you please write down at the side? When you have n choose 0, the answer is just going to be 1. So it helps you to calculate things much faster. You don't have to rely on a calculator too much. Okay, when you see n choose 0 means any number choose 0, the answer is 1. Okay, why? Because actually n choose 0 is basically, I told you guys, it got to do with probability. Okay, it means that if you have n, it can be any number. 5. Let's say you have 5 numbers, what is the way for you not to choose any? How many ways do you not choose any? 1. Basically, you don't choose. Okay, so there's one way. Okay, if you don't understand, don't worry. Okay, it will not be tested in probability. It will only be tested if you go to Poly or JC. Okay, next one. The next thing that we notice is that what is 5 choose 5, 4 choose 4, 3 choose 3, 1 choose 1. What do you think is the answer to all of this? Enter in your calculator. What do you think the answer to all of this is? Also 1. Right. It's also 1. Okay? Why? Because let's say you have 5 numbers. What is the number of ways you choose all 5? Only one way. Okay? Only one way. Okay? So here, n choose n will also be 1. Okay? N choose n will also be 1. Okay? Now, next one. What is 5 choose 1, 4 choose 1, 3 choose 1, 2 choose 1? What do you notice about all these? They are whole numbers. Try. Sometimes you must try for you to be able to remember such things. If you have a number, choose 1. 5, 4, 3, 2. So what we notice is that if you have n choose 1, what do you think this is going to be? N. Okay? So here, just 3 things for you to remember. These 3 things is actually quite useful. Okay? Please jot it down somewhere. Okay? It can help you to simplify a lot of things. It helps you to simplify a lot of things so that you don't have to calculate so much. Alright, okay, let's move on. Okay, we left off in example number 3 on page 4. Okay, we left on example number 3 on page 4. So let us quickly do this question together. Okay, if you have memorized the expansion, for those of you who are still memorizing, you must commit yourself to memorize it. Okay, so how do we expand this? First thing I noticed that this is raised to the power of 7. So I know my n is 7. So I'm going to follow the pattern. I always start from 0. So n choose 0, 7 choose 0. I write down my first term is 1. I have my second term is 4x. They want me to just write down 3 terms. So that's what I'm going to do. 7 choose 1, 1, 4x. 7 choose 2, 1, 4x. I am done because that's all they want me to do, the first 3 terms. Okay? I can now put in the powers. I remember the first one is just 7 minus 0, that gives me 7. And this in descending powers, right? The second one is in ascending, so start from 0, 1, 2. Okay, now I can simplify 7 to the power of, no, it's not 7 to the power of 0. 7 choose 0, anything choose 0 is just 1. So this one is just 1. 1 to the power of 7 is basically also 1. 4x to the power of 0 is also 1. So I can immediately write down this 1. 7 choose 1 gives me 7 times 4. 7 times 4 gives me 28x. And the last one, 7 choose 2. 7 choose 2, there is no easy way to do it lah. Use your calculator. Alright, enter in your calculator. 7 choose 2. I get 21. 21 times 4 square. That gives me 336x squared. Can, ladies and gentlemen, just enter in your calculator, and this is the end of binomial theorem. Like I say again, in your exam, coming up in week 8, so we do have a little bit of time. Okay, but it's coming up week 8, you will have a binomial expansion like this, and it will be about 6 marks. Ridiculous number of marks. Okay, because we give marks for expanding and also giving marks for simplifying. Okay, so it's really ridiculous amount of marks for just memorizing this really small portion. But I can tell you many a times you sit down at the exam and sometimes you just freeze there because you don't even know how to start. If you don't practice, you definitely won't be able to do the expansion of this. Alright? Okay, so let's quickly move on. Now, they want us, they say hence find the expansion of these two terms up to the term in x squared. So how are you going to do that? Okay, so we already got these two terms up there. We got this and this. If I want to find the expansion up to the term x squared, that means I can just write it down. 1 minus 6x plus 15x squared plus ... multiply by 1, 28 plus 336x squared ... Now, you do not have to expand every single one. If your expansion leads you to a final answer that it is greater than x squared, you don't do it. Alright, so let us follow the chain of thoughts. I have 1 times 1, yes, that is 1, is still less than x squared. I have 1 times 28x, yes, that is still less than that. 1 times 336, yes, so plus 336x squared. Let's move on to the second one. Negative 6 times 1, yeah, it's still going to be less than that. Okay, how about the next one? Negative 6 times 28x, yes, that is still equals to x squared or less than. Okay, so let's use the calculator. Negative 6 times 28, that gives me negative 168x squared. Okay, how about next one? Negative 6 times 336x squared. Should I proceed with this one? No. Why shouldn't I proceed? Because they only want us to expand up to the term x squared. And if I were to expand 6 with x squared, I'm going to get x cubed. Okay, so I don't need to do that one. It's a waste of my time. Okay, so I'll move on to the next one. 15x squared times 1, that gives me, of course, plus 15x squared. Do I have to do the next one? No, I don't have to, because I'm going to get x cubed and then, of course, x to the power of 4. So I'm going to stop here. My final answer will just be the simplification of this. Okay, because of space constraints, let me just write it down here. So I'm going to get 1 plus, this is the x, this is the x. So it's 28 minus 6, give me 22x. The rest are all x squared. So 336 minus 168 plus 15, that gives me 183x squared. Okay? So this is the final answer over here. Okay, this is the final answer over here. Okay, so it's a relatively simple question. You just need to do it slowly. I would say binomial theorem is perhaps one of the simplest chapter in A Math. Yes. Don't have to actually, because they basically just want you to expand until x squared. But ... just means that actually there are more terms behind. But no, we will not penalize if you don't put the dot dot dot. Okay? Okay, example number 4. This one is a little bit more tricky. Okay? They say use the expansion of 1 plus p to the power of 4 to expand 1 plus x squared to the power of 4. So let us expand 1. Okay, this one space is constrained, so do a little bit smaller. Okay, let us expand this thing first. Okay, let us expand this thing first. So how do we expand this thing? 4, 0, 1, p plus 4, 1, 1, p plus 4, 2, 1, p. Okay, can you just expand along with me? 4, 3, 1, p, and last one, plus 4, 4, 1, p. Alright, and then you write down the powers. This one is 4, 3, 2, 1, 0. This one is 0, 1, 2, 3, 4. Okay, so you should simplify. Once you're done simplifying, you should look up and check your answer with mine. Okay, once you are done expanding 1 plus p to the power of 4, look up, check your answer with mine. Okay, it's important that you go through that whole process. Okay, it's important that you go through the whole process to understand how are you going to expand it. Alright, to understand how are you going to expand this. Okay, I'll give you guys another 30 seconds. Yeah. Wait, 4, choose 3. Yeah, it's 4. My apologies. Okay, because they say that use the expansion of 1 plus p to the power of 4 to expand. No. So later you're gonna expand this until x squared only. But I think this part you still must expand all the way to the power of 4. Okay, for the part A. Okay, are you guys done until here? Okay, if you are done until here, now let us think. Okay, since this is basically a hence question, right? If they are asking you to use this expansion to expand this, that means you need to figure out what the value of p is. So if you compare these two terms, let me zoom it in. If you compare these two terms, what do you think p is? X plus x squared. Alright, so you can see here that your p in this question is x plus x squared. Okay, so all we have to do is substitute in this thing inside the above. Okay, so the expansion of it is 1 plus 4. Whenever you see p, replace it with x plus x squared. 6x plus x square plus, here you don't have to continue anymore. Why you don't have to continue? Because they only want you to expand as far as the term x squared. Because anything that is cubed, you will not give you x squared anymore. Okay, so we can stop over here. Okay, so here you just need to expand this, and all of you should be able to expand this, right? 1 plus 4x plus 4x squared. This thing, how to expand? Do you need binomial theorem to do it? No need. This one you memorized it in your E-math, right? So plus 6a squared plus 2ab plus b squared. Okay, do you guys remember this? Okay, let's do a final one. 1 plus 4x plus 4x squared plus 6x squared plus 12x cubed plus x to the power of 4. But we can ignore all the powers that is larger than x squared. So actually this one I don't need. Okay, this one I don't need. That makes it a lot simpler. 1 plus 4x plus 10x squared. Can or not, ladies and gentlemen? Okay. Again, I'm going to explain again. Until here, everyone can understand?
No.
Until this part, the expansion of 1 plus p to the power of 4. This one can understand, right? Okay, so the question actually wants us to use this binomial expansion. Okay, they want us to use this binomial expansion to expand this really complicated expansion. This really complicated trinomial expansion. Trinomial because there is 3 terms, right? So how do we do that? We can actually make use of the fact that if we already know the expansion of 1 plus p, I'm just going to compare these two things. So I compare these two things, I realize that actually p is actually my x plus x squared. Do you notice that? Your p is equals to x plus x squared. If we let p be x plus x squared, can you see that actually these two are the same? That means you replace this x plus x squared with p. Okay? That means if you can just replace this thing with p, then actually these two are the same thing. Okay? Who is confused about this part? This thing is just basically replacing the x plus x squared with p. Okay? But because we already know how to expand 1 plus p to the power of 4, this is something that we already know. So I only need to replace the p with x plus x squared. So I'm going to do that. So when you see this, okay, I'm going to let p be x plus x squared. So what I'm going to do is, I can ignore these higher powers because the question only wants me to expand until x squared. So I'm just going to substitute the value of p as x plus x squared. Okay, I'm going to take this and I'm going to substitute it in. Okay, when I substitute it in, I just need to expand it out. This one, it will just be your normal expansion already. Okay, so I can ignore all the terms that is higher than x squared because the question asked me to ignore them. Okay, the question asked me to ignore them, so I'll just ignore them. I simplify and I'll get here. Okay, I'll get this here. Okay? Okay? Now let's move on to the second one. Substitute x equals to negative 1.01 into the expansion to estimate the value. So part 3, they want us to substitute in the value x is negative 1.01. Now if you were to substitute this value inside here, what are you going to get? Let's try. 1 plus 4 negative 1.01 plus 10 negative 1.01 squared. What are you going to get? One plus 4 times 1.01 plus 10 negative 1.01 squared. Okay, you should get 7.161. Okay, you should get 7.161. Now, do you think this is going to be a good estimation?
No.
Why?
Because I don't think so.
Okay? Okay guys, this is a very common question. Okay, and the answer to this is always the same. Okay? I want you guys to think about it. Now, in this expansion of this 1 plus 4, 1 plus p to the power of 4, we have conveniently ignored all of the higher powers, right? Actually, in this case, this thing needs to be until the raised to the power of 4, but we ignore all of the higher powers. Now, in this case, we are letting x be 1.01 or negative 1.01. And if you know anything about raising something to the power, if the number is greater than 1, if you raise it to a higher power, does the number get bigger and bigger and bigger?
Yes.
So what we are doing in this case is we are ignoring the higher powers. Okay? So without even doing any calculation, do you think this will be a good estimation? No. Okay? The reason is because number 1, we are ignoring the higher powers and x is greater than 1. Now, when can we ignore the higher powers? When can we ignore the higher powers? when x is
1.
when x is a very small number. Okay? For example, I give you an example. If in this case, and this is a very common exam question, if x is actually 0.01, if we were to ignore x to the power of 3, do you think it's okay? I think it's okay. Can you try? 0.01 raised to the power of 3 is a really tiny number. Okay, so we can ignore it. But if the number is greater than 1, you cannot ignore it. Okay, you cannot ignore it. And in fact, I give you an example. Why we can ignore to the power of 4? Okay, even if it's not so big. Okay, I say this 0.1. If I raise it to the power of 4, what do you get? 0.1 to the power of 4, you're going to get 0.0001. Okay, so the only time we can ignore a number if it is less than 1. Okay, we can do an estimation is if it's less than 1. So in this case, please write down the explanation. Determine if the choice of substitution is a good one. The answer is no. Okay, so this is part 2. The answer is no. Why? Because firstly, number 1, we ignore the higher powers. Okay, we ignore the higher powers. Now, number 2, the value of x that we use for the substitution. The value of x is greater than 1, or the modulus of x is greater than 1. Doesn't mean that it's negative 1.01, the number is okay, because modulus means we don't care about the signs. Okay, modulus means we don't care about the sign. You see these 2 lines under the x is called modulus. That means the value itself. Okay, you ignore the negative sign, is more than 1. So when we square it, we cube it. Okay, it's going to be a number that is significant. We cannot ignore it. Okay, so 2 things. Because number 1, we ignore the higher powers. And number 2, why we cannot ignore the higher powers? Because the modulus, the value of the x, is actually greater than 1. Okay, so you cannot ignore it. Okay, this is a very common exam question. Can you put a star beside it? Okay, please put a star beside it. It's always tested one. Would it be tested for your WA? I don't know. But this one is not so easy. Your WA is actually very easy. So do you think we tested? I don't know. Okay, let's move on. Okay, let's move on. Now we are going to expand a plus b to the power of n. Like I said, if you were to go and study the textbook, there is 2 formulas for the expansion of binomial theorem. Okay, there is 2 formulas. You will always see this formula over here. This formula at the start. Where is it? I passed already. Here? Here. Okay, you will always see this formula, but like I said, in the textbook, like I said, don't have to memorize this formula. Because sometimes memorizing 2 formulas is very confusing. Just memorize 1 will do. This formula will only work if this is 1. Okay? But for those of you who are interested in how to derive this thing, we need to first use the other formula to actually help us to derive this part, a over b to the power of n. Okay, I'll just go through this, okay, but you don't have to memorize this. They will never test you derivation. I just want to tell you how it comes about. Okay, so this one, if you were to expand this, it will be n choose 1. Okay, if you follow this, then this will be a over b. N choose 2, a over b. And n choose 3, a over b cubed. Alright? And of course plus dot dot dot. Okay? So, once you get here, I'm going to try to bring the b term up. So, I'm going to get n choose 1, a, b. I'll just bring it up so it's negative 1. Plus n choose 2, a square b negative 2 plus n choose 3 a cube b negative 3. Okay? And because they want me to find derivation of a plus b to the power of n, but I only know 1 plus a over b to the power of n, I realize that what I can do is to multiply by a to the power of n. Because if I multiply by a to the power of n, same powers, I can now push in the terms, so it will be a plus a, sorry, this is b. My apologies. Okay, this is b, and I'm going to get b plus a to the power of n. Okay? So what I realized that, I only need to actually multiply by this b to the power of n. Right? Do you notice? I just need to multiply by this b to the power of n, and I would be able to get my answer. So what I can do here is I will multiply this by a b to the power of n. Multiplying by b to the power of n is the same idea as multiplying to every single term over here. Okay, it's the same as multiplying to every single term over here. So if you multiply to every single term over here, okay, basically you are going to get b to the power of n here. Here is going to be b to the power of n. Here is going to be b to the power of n. Here is going to be b to the power of n, dot, dot, dot. And if you do that, okay, if you do that, you realize that here is going to be b to the power of n plus n1, a, b, same base. This is going to be n minus 1, a2, this will be b, n minus 2, n3, a cube, b, n minus 3, and goes on and on and on. Okay, it goes on and on and on. Okay, so that is how, if you actually do that, eventually here you're going to get a to the power of n now. Okay, the other side you're going to get a to the power of n, if you really want to do out the whole thing. Okay, and that's how we actually get this formula. Okay, and that's how we actually get this formula over here. But like I said, is derivation going to be tested? No, it will not be tested. Okay, but for those of you who are a little bit interested in doing derivation, okay, interested in how things are, then yeah, that's how you actually derive it. Okay, if you're not interested, then forget it. What is the term that I want you to memorize? In fact, this one sometimes it may look a bit confusing. Okay, so just write it down one more time. Just one more time, write it down. The expansion of a plus b to the power of n, the one that I asked you to memorize, is just, you just need to n to the power of 0, write down the first term, write down the second term, then n, just do 3 of them. A, b, and one more. A, b, okay, dot, dot, dot. Alright, and this one is just going to be n, then this is n minus 1, n minus 2, this is going to be 0, 1, 2. Okay, this is going to be 0, 1, and 2. Alright, now, over here, if you were to compare the thing that I asked you to memorize and the thing on top, then some of you might say, hey, but it looks a bit different and it's not like the same. Why? It's because this is a lengthier version of this, right? But actually, if you take a look, what is n choose 0? Just now I told you guys, anything choose 0 is 1. This b to the power of 0, anything raised to the power of 0 is 1. So actually, that's why you get a to the power of n. Can you see that? Okay? Now, the reason why I want you guys to write down this thing is because very commonly in the exam, and this one will come out. I'm not afraid to tell you because it always comes out. And this one will come out. Okay? This one is new. Is sometimes they want you to find the term, the third term of the expansion, or the fourth term of the expansion, or maybe they want you to specifically write down what is the fifth term of the expansion. Okay? So for example, in this case, if I want to find what is the second term of the sequence, T2. Okay? If I want to find the second term of the sequence, do I actually expand everything out and then I say, oh, this is the second term of sequence, so I'm going to write down, oh, okay, so this is n1, this is a n minus 1 to the power of b. Do I do that? No. Let us try to find a pattern. Okay, let us try to find a pattern. Okay, do you notice something? And this one, try to follow along with me. Okay, try to follow along with me. And actually, maybe let me change this up a little bit so that it's easier to see the pattern. Okay, instead of the second term, let us go with the third term. Okay, so this one is 2, and this one will be 2, and this one will be 2. Alright? Okay, now look closely because this one, if you miss it, then you might find a little bit more difficult for you to catch up. Okay, now if I want to find the third term, I realize that this one is going to be n choose 2, and this 2 over here, okay, this 2 over here is always going to be 1 smaller than this 3. Do you notice that? This 2 over here is always 1 less than this thing over here. If you look at all the other terms, this is the first term, right? This is the first term. You notice that this number here is always going to be 1 less than the term that you want to find. Okay? This is the second term. This is 1. It's always 1 less. This is the third term. This is always going to be 1 less. So if I were to try to generalize things, I'm going to say that this number over here, I'm going to generalize things. So I'm going to say this number over here, if I say this is the number r, what term do you think this thing is going to be? R minus 1? R plus 1. Okay? And this term over here, this is my A and this is my B. You notice that this thing on the top is just n minus 2. So if this is R, this will be n minus R. And this is R, this will be R. Because if this is 2, this is 2. Okay? Now, this thing, can you please write it down? You must memorize as well. Okay, you must memorize as well. Yes. Yeah. Okay, I know there's a lot for you to memorize, but actually really not really. Okay? Because there is only these 2 formulas you need to memorize in this chapter. Only these 2 formulas you need to memorize in this chapter. Okay? Only these 2. Alright? So what is the formula you need to memorize? T r plus 1 is equals to n to the power n choose r, a n minus r, b r. Okay? What is n? What is n? N is the power that you raise your binomial to. Okay? N refers to the power that you raise the binomial to. Okay? And then, what is R? R is not the term of your sequence. Okay? Because actually if you realize, your R will start from 0. And what do you think is the maximum R value? N. Okay? So actually R, can you please write down these 2 because when you revise, you definitely going to be confused. If R is an inequality, R is going to be in between 0 and n. Okay? R is basically going to be 0, in between 0 and n. And what is n? N just means the power, the binomial is raised to. Okay? It is the power that binomial is raised to. Okay. Okay, I'm just going to write down one example over here. Okay, this one don't need to copy. I'll just write it down to just check whether you understand this part. Okay, but like I said, actually this chapter is really just these 2 things. Alright, so let's say I have a binomial expansion of, let's see, 2 plus x to the power of 5. Okay, let's say I have this binomial expansion of 2 plus x to the power of 5. And I specifically, okay, or let's make it even more ridiculous lah. Okay, let's say I have a binomial expansion of 2 plus x to the power of 99. Okay, and I want to find what is the 96th term. Okay, I want to find what is the 96th term. So T96. How am I going to do that? For some of you who want to actually do the expansion, are you really going to do the binomial expansion of this until to the power of 99? No, right? You can straight away apply the formula. okay, you can straight away apply the formula. If this is the formula, how are you going to do it? It's not going to write down. Okay, I'll just explain to you. Okay, you want to find the term 96. The formula is for TR plus 1. Okay, so the first thing you are going to do is you are going to ask yourself, if R plus 1 is equals to 96, then what is your value of R? 95. Okay, so in this formula, you just need to replace the R with 95. And what is your N in this case? What power is the binomial raised to? 99. Alright, so you just need to substitute this. Your A is your 2, your B is your X. So this one is just going to be 99 minus 95 is 4. This will be X to the power of 95. Okay, so this is your answer. Just enter this in your calculator and you're done. This will be about 2 marks. Okay, this will be about 2 marks. Okay? Now, let us quickly go and do this question. Okay? Okay. Find the first 4 terms in the expansion in descending powers of x of the following. Okay, so we want to find the descending powers of x of the following. How are we going to do that? Let's do this now. We are going to apply the formula. I'll go through part A with you, and then the rest you're going to do by yourself, okay? So the formula, 6 choose 0, 3x, I have a 2, 6 choose 1, 3x, I have a 2, 6 choose 2, 3x, I have a 2, and one more because they want the first 4 term, 6 choose 3, 3x, 2. Okay, then I fill in the powers. This is 6, 5, 4, 3. And this is 0, 1, 2, and 3. Okay, so just enter this in your calculator. Actually, you guys are very lucky. This WA for A Math is pushed to week 6. Can you imagine if you have to study for E Math and A Math?
Yes.
I think by when? Week 6 Good.
First day, yeah.
Next Monday. The first day of WA1.
Good.
Then WA.
Next Monday.
Next Monday. Can you complain?
No, I love it.
You love it?
I love it. So that week 8 you only have A Math.
Wow.
Then you guys can focus on A Math.
Wow.
Wow.
I must be biased to my own subject. Okay, can you please quickly expand this and double check your answer? Okay, you should be able to expand this. Don't try not to make any mistakes. Try to do this. If you are okay with this one, can you do part B? Okay, can you do part B as well? Yeah, I think that's all. Part C don't need to do lah. No lah, do part C also because I think that one has merit.
Wait, how about
Okay.
we do part C instead of part B?
No, part B also you need to try because it has a fractional.
Yeah.
Yeah, so it's good. It's good practice. Okay, I will do part B up there. Please check your answer with mine also.
it just Q and
The negative, the divide by x means is same base means you subtract the powers. Okay, just do first, later I go through.
你加好，加好一点。
Okay, if you are done with part B, can you look and check answer? This one I will explain a bit more lah, because I think some of you got some problem with the powers. But in general, okay, if for example you know this is x2 to the power of 6, so this is x to the power of 12, right? But you have a fraction here. So this is x to the power of negative 2, right? Because if you distribute the powers here, it's x to the power of 2, but if you bring it up, it will be x to the power of negative 2. So if you have negative, same bases, this is x to the power of 12, this is x to the power of 2, what you do? Combine the powers or add the powers, you get x to the power of 10. Okay? So this is the revision of indices, This is the revision of indices, so you guys just did the test. Okay? So I'll give you guys another maybe about 30 seconds. Can you check your answer?
Oh, I got it.
Don't worry, later I'll go through. Later I'll go through.
So will this kind of questions be less?
Yes, for the more difficult ones, yes. End of year, I can tell you very frankly, end of year, you can be prepared to vomit blood. Okay?
Well, you already said the paper.
Okay, end of year you can be really prepared to vomit blood, because most likely the paper will be done by the HOD of math. Miss Tam.
Will she be our math teacher?
Yeah, she will be your math teacher. So her paper will definitely have standards. Okay, her paper will have standards, unlike mine. Mine no standard. Okay? Okay, come. Let us go through this one. Listen. Okay, how do you simplify? Let's take a look at this one first. I think the expansion, no one has a problem. Okay, but when I look at this, 8 choose 3, I just use my calculator. 8 choose 3. So this one is 56. X squared raised to the power of 5. The powers will just multiply each other, so it's x to the power of 10. Okay, until here everyone okay, right? Then I have negative 2 raised to the power of 3 is just negative 8. And I have x to the power of 3. Until here, everyone okay? Everyone okay, right? 56 times negative 8. 56 times negative 8, I'm going to get negative 448. I'm going to get x to the power of 10 divided by x to the power of 3. What do you mean why? Okay? Can you see that? Until here, anyone confused now? This is the numerator, this is the denominator. So if I multiply them together, the negative 8, I multiply 56, this negative 10, I bring over here. Now, if you have the same base, divide, what happens to the powers?
Minus.
Yeah. Hey, we just did a test there. Okay? So it's what? Die already.
Prepare the cross.
Okay, that is the reason why this one is x to the power of 7. Okay, so I have 448 x to the power of 7. Can? Okay? You guys look very defeated. Come on. A few more minutes only. Example number 6. Let's go. Huh? Oh yes, part 3, sorry. Okay. C. Let's do part C first. Yeah, 4 more minutes. I'm fighting against time. Okay, let's do this. Last question of the day. Okay, 2x plus 1 raised to the power of n. Same thing. I have n choose 0, 2x, 1. Plus n choose 1, 2x, 1. N choose 2, 2x, 1. And And how many terms do I need? 4, right? 1, 2, 3. One more. And choose 3, 2x1. Alright, so I just need to fill in the powers. This is n. This is n minus 1, n minus 2. This is n minus 3. And then of course this is 0, 1, 2, 3. So let's simplify this thing. N choose 0 just gives me 1. So my final answer in this case is just 2xn plus n choose 1 is just going to be n. So I'm going to get 2x n minus 1 plus n choose 2, 2x n minus 2, and lastly n choose 3, 2x n minus 3. Okay, you can leave your answer like this. You can leave your answer like this. Okay, we have about 1+ minute left. I think I will not continue. I'll continue during the next lesson. Huh? Okay, the next lesson